Welcome to Algebra, standard form for linear functions. In addition to the slope-intercept form we discussed in the last lesson, this is another equation format in algebra, used to represent the graph of a line, and is the ideal format when actually designing an equation to solve a problem. In this lesson, we'll explore how it is used to set up the solution to a real-world situation, and then how to convert it into slope-intercept form for graphing and finding the answer. Let's check it out. Standard form, ax plus by equals c, is often used when dealing with a real-world situation with a two-part answer, two unknown values, two variables, with several possible solution combinations, setting up a function or equation to help find those possible solutions. Let's take a simple example. Say you have $30 to spend to buy meat for a cookout, specifically ground beef at $2 a pound and chicken at $3 a pound. You want to know what combinations of pounds of ground beef and chicken can be purchased for exactly this amount, so you can better plan for the event. We'll use X to represent the ground beef, with A being the cost per pound at $2, and Y to represent the chicken, with B the cost per pound at $3. The budget amount of $30 substitutes for C. The resulting equation in standard form is 2x plus 3y equals 30. Now that you have the standard form equation set up, you are ready to solve the problem. To do this, you must convert it to slope-intercept form, y equals mx plus b, which will make it easy to graph and find all the possible solutions, which may be several. To convert this standard form equation to slope-intercept form, you must use the equation manipulation techniques learned in earlier lessons. First, we move the entire x term to the right side of the equation by subtracting it from both sides, resulting in the equation shown, 3y equals negative 2x plus 30. To best fit the format, y equals mx plus b, we put the x term in front of the constant on the right side. We divide the left side by 3 and then cancel to isolate the y term. And then on the right side, divide the x term by 3 and then the value 30 by 3, and we get y equals negative 2 over 3x plus 10. We now have our equation in slope-intercept form, ready to graph to find all possible solutions. We learned in the last lesson how to graph an equation in slope-intercept form, which is what we do now. We locate the 10, the y-intercept, on the y-axis, and then start working the slope down 2 and over 3, getting a new point each time. All these points represent x-y combinations that indicate the number of pounds of beef and chicken you could purchase for the cookout. You could have 0 pounds of beef and 10 pounds of chicken, or 3 of beef and 8 of chicken, 6 and 6, 9 and 4, 12 and 2, or you can buy all beef and no chicken at all. Now, the example we just worked through is something you will do more and more as you learn how to use these algebra tools to solve real-world problems. For now, we'll just focus on the process of converting from standard form to slope-intercept form. Let's check out this example. To find the slope and y-intercept, you need to solve for y. First, move the entire x term to the right side of the equation. To isolate the y variable, divide all parts by 2, the coefficient of y, and you get y equals negative 3 over 2x plus 3. The slope is negative 3 over 2, and the y-intercept is 3. Let's try these. Find the slope and y-intercept. We move the x term to the right side, we divide all parts by 4, the coefficient of y, and we get y equals 5 plus 1 over 2x. We rearrange it into slope-intercept form, and we see that m is 1 over 2 and b is 5. In this other equation, again we move the x term to the right side, we divide all parts by the coefficient of y, negative 2, and we get y equals negative 4 plus 1 over 2x. Rearrange it into slope-intercept form with the x term first, and we see that m is 1 over 2 and b is negative 4. Let's try these. We move the x term over, divide all parts by 2, and we get y equals 6 plus 3x. Rearrange into slope-intercept form, y equals 3x plus 6, m, the slope is 3, b, the y-intercept is 6. In the second equation, we again move the x term over, divide all parts by 6, y equals 2 plus 4 over 3x, rearrange into slope-intercept form, m is 4 over 3, and b is 2. On this third one, again, we move the x term over, divide all parts by -9, and we get y equals 3 plus 2 over 3x, rearrange, y equals 2 over 3x plus 3, m is 2 over 3, b is 3. We need to emphasize a common issue. When solving for y, to move the x variable term to the right side, you add or subtract the entire x variable term. To isolate the y variable, only divide by the coefficient. If the coefficient is negative, you must include the negative when dividing. Let's try another one. Here we solve for x by moving the x term over, divide all parts by 3, y equals 3 plus 1 over 3x, rearrange into slope-intercept form, and we have y equals 1 over 3x plus 3. Now we plot the point, the y-intercept, and slope to graph the line. Y-intercept is at 3. We do the rise and the run, which is 1 and 3. We have a new point, and we draw a line through those 2 points. In this situation, it's not quite standard form, although it kind of looks like it. The x term is listed second. Still, the solution is the same. We move the x term over, divide all parts by the coefficient of y, which is 3, and we get y equals -2 minus 2 over 3x. Rearrange into slope-intercept form, and we get y equals -2 over 3x minus 2. We plot the point at -2. We do the rise and the run, which is down 2 and over 3. We draw a line through it, and now we have graphed the line. This equation is almost in slope-intercept form. The x term is already on the right side, but we still have a coefficient with y. So we must divide by -2, which gives us y equals -2x plus 2. We plot the y-intercept at 2, we go down 2 and over 1 for the slope, and then we draw the line through the 2 points. There is a shortcut process that allows for a quick and simple conversion from standard form to slope-intercept form without going through the equation manipulation steps. From standard form, the slope can be found by taking the values of a and b and putting them into this formula, m equals -a over b. And the y-intercept can be found using this formula, b equals c over b. In the standard form equation shown, first identify the 3 values of a, b, and c. A is 2, b is 3, c is 30. This is the same equation we used in our opening example. We use the shortcut to get the slope, -2 over 3. And we use the other shortcut to get the y-intercept, 30 over 3, which divides to be 10. And so the slope-intercept form is y equals -2 over 3x plus 10. This question says which answer choice below is the same as y equals -2 over 3x plus 3. We're going to solve each answered choice to see which one matches this equation. Use the shortcuts you just learned about. M equals -a over b, and b equals c over b. In choice A, we identify a, b, and c as 2, 3, and -9. We use our first formula, and we get -a over b is -2 over 3, which gives us the slope, -2 over 3. b is -9 over 3, which simplifies to -3. So our slope-intercept equation is y equals -2 over 3x minus 3. This does not match our original equation. Let's try choice B. We identify a, b, and c as 3, 2, and -6. We plug in our formulas and we get -3 over 2 for the slope. We get -3 for b, and the equation is y equals -3 over 2x minus 3. This doesn't match either. Let's try choice C. A is -2, b is 3, c is 9. We do our formula and we get 2 over 3 for the slope. We get 3 for the y-intercept. Our equation is y equals 2 over 3x plus 3. This still doesn't match. Let's try D. A is -2, b is 3, c is 9. We plug in our formula. M is -2 over 3, b is 3. The equation is y equals -2 over 3x plus 3. This does match, and we have found the answer choice that matches the original equation.